Hi friends, welcome to Curie Electronics. Today we are going to solve Iprc Isro Propulsion Complex Mahendragiri 2018, not 2018, it is 2016. It is 2016 Technician B Electronics question paper. So you could WhatsApp me to get any of these previous years question papers. Almost 10 years question papers are available. That is, if you are an electronics technician, you can ask for the technician's question paper. If you are a fitter student, you can ask for the fitter question paper. If you are a technical assistant electronics, let's say if you are a diploma holder in electronics, then you can ask for the technical assistant question paper. If you are a mechanical diploma holder, you can ask for the mechanical question paper. Or if you are an electrician, you can ask for the electrician question paper, as well as MC questions of railway and SSCJ. Almost 3000 questions are there. That's also available. I am not going to charge you anything. Just WhatsApp me. I may ask you to subscribe. That's all. I will send you the question papers in WhatsApp. Okay. So today, anyway, we are going to solve the electronics mechanic question paper 2016 IPRC. IPRC. So ISRO propulsion complex Mahendragiri. This question paper was on asked on 28/8/2016, and time was 1.5 hours, and total there were 60 questions and 180 marks. So we will solve three parts. Each part we will take 20 questions. So we'll go to the first question. Question number 1. The fundamental frequency of the third harmonic of 50 Hz is. So third harmonic is asking. So fundamental frequency. What fundamental frequency? Fundamental frequency equals 50 Hz. So third harmonic, it is like a third harmonic. Third harmonic. If you want to get third harmonic, what you will do? Fundamental frequency multiplied by 3. So 3 multiplied by f, fundamental frequency. So 3 multiplied by 50, you will get 150 hertz. So this is the third harmonic of 50 hertz. So if you want to fifth harmonic, you will multiply by 5 multiplied by 50. You will get 250 hertz. Question number 2. What is the peak to peak voltage of a 2 volt RMS sine wave? So this question has repeated many times. So this is a sine wave. Then this value is known as the V peak to peak. V peak to peak. V peak to peak. And this is known as, it's all, assume that it's a similar amplitude. Okay, no change in the amplitude. Okay, if you change in the amplitude also, we will calculate like this. This should not be change in amplitude, should be same amplitude. Okay, let me draw it, or else you may get doubt means problem. So I will draw it properly once more. So okay, now somewhat matching. For this sine wave, the peak to peak value means this is the peak to peak value. V peak to peak. V peak to peak. This is the V peak to peak value. That's what we have to find in this question. And this value is known as the V peak, or this is also V peak. Now V peak equal to root 2 multiplied by VRMS. What is the root 2 value? 1.414 multiplied by what is the VRMS? 2 volt. So roughly if we take, we will multiply it 8 to 8 to 2.828 volt. That's a V peak. That's what V peak. But we need V peak to peak. So if you 2 times of V peak to peak equal to 2 times of V peak. So 2 multiplied by 2.828. So roughly what I will do, I will not take all this. I will take 2.8 multiplied by 2, because in the option now itself I know it is 5.6. 5.6. So the answer is option D. So remember, you can WhatsApp me and get the question paper for all these. Almost 10-year previous question paper, and for SSC and JE there are more than 3000 questions are there to practice with answer. Oh, sorry. 1 second. Okay. Because I pressed some other button. That's why it went. Okay. Question number 3. The formula for electrical current is, what is Ohm's law? As per Ohm's law, V equal to IR. So what is the question? Electrical current. So I equal to V by R. So voltage upon resistance. What is the total effective capacitance of two 0.25 capacitors connected in series? So here two capacitors are connected in series. We have to find the equivalent capacitance across this. See, equivalent we have to find. The C1, C2. What is the, both values are same. So 0.25 microfarad. Here also 0.25 microfarad. Then what is the equation? C equivalent equal to C1 C2 upon C1 plus C2. If you saw, okay, now, but both the capacitors are having same value. So C equivalent equal to C upon N. N is the number of capacitors, same value capacitors connected in series. So what is the value of C? 0.25 microfarad. If you divide by two capacitors, that's why I am dividing by 2. Just like it is similar to resistors connected in parallel. So we will get 0.125 microfarad. So that is the answer, 0.125 microfarad. Question number 5. The common material used in wire wound resistor is, that is manganese. Manganese has a good temperature coefficient. That is why we use manganese. So if there is a increase in temperature, very slight variation will be there in the resistance of manganese. Question number 6. Zener diodes are most commonly used in. Zener diodes, we know it's used as a voltage regulator circuits. It is used in voltage regulator circuits. So here in the options, power supply circuit is the most suitable one. So power supply circuits. Question number 7. The figure shown below is a schematic representation of. This is circuit. This is a, see, there is no components are there, but there is a feedback from the output to the input. This circuit is a voltage follower or buffer. This can also be called as a buffer or voltage follower. Similarly, we'll see one more circuit here. We have op amp here, op amp, negative terminal, See, one capacitor is connected to the input. Here input signal is coming. On the feedback path, one resistor is there. R and C. This is a differentiator circuit. Differentiator. This is differentiator. Is a differentiator circuit. Similarly, if the capacitor is there in the feedback path, then it is an integrator circuit. Just like this. We have a resistor in the input side, and in the feedback path we have a capacitor. This is output. What the circuit here is the output. So capacitor is there in the feedback path, then it is a integrator. It's a integrator circuit. Integrator circuit. This is an integrator circuit. So we'll go to the next question. Question he has given, okay. XC he has given XC equal to 31.83 kilo ohms when C equal to 0.005 microfarad. Now the question is, if the frequency of source that Vs is 1 kilohertz, what is the value of the capacitive reactance of circuit if the capacitor value is changed to 0.01 microfarad? Okay, so options, all values are there. So Xc equal to 1 upon 2 pi Fc, that is the equation. So 2 multiplied by pi multiplied by F, frequencies 1 kilohertz, that is 1000 hertz. What is the capacitor value? Capacitor value he has changed to 0.01 microfarad, that is 10 to the power minus 6. 10 to the power minus 6. Now we will simplify. Once we simplify, we will get the answer. We will try to simplify. So 10 to the power minus 6 when it goes up, it will become 10 to the power 6. Now if you multiply these two, what you will get? We will get 10, will get 0 0 get cancelled, 10 you will get 10 multiplied by 2 into pi. See here, all answers are having different, these answers, when I see the answers, because I don't want to simplify all these decimals, everything. So these are some, there is a little variation in the values. There's a more variation in the values. So what I will do, 3.14 I won't take, I'll just take 6 only. 2 multiplied by this pi equal to 6, I will get it. 6 I will take it. 6 I have put here. This is over. Okay. Now 10, if I cancel, I will get 10,000. 1, 2, 3, 5. Because this and 1 0 will get cancelled. So it will be left with 10 to the power 5. 5 upon 6. Now whatever I get, divide. So all are having k. So I will do, what I will do now, 100 divided by, I can just write it like this, 100 by 6 into 1000. 1000 I can write it 1k later. Okay, so what I will do, 100 upon 6. 15 times if I take, I'll get 90. 16 times if I take, I will get 96. So 16 and 16 multiplied by 1000, I will get approximately, that is 16k. So 16 kilo ohms I should get. Now 16 kilo ohms is there, not there, but I know actually my pi value is 3.14, but I have considered only 3. So the answer is option C, 15.9k. So you are not going to solve with each decimal point everything. Then it will take more time. Question number 9. Electric current is the flow of which of the following? All of us know electric current is the flow of electrons. Question number 10. Question number 10. In a simple DC circuit with a constant voltage where the resistance increases, constant voltage is constant, V constant. V constant, if we increase the, where the resistance increases, what happens? Current decreases, current will decrease. Question number 11. The magnitude of the induced EMF in a coil is directly proportional to the rate of change of flux linkage. This is the Faraday's second law. This Faraday's second law of electromagnetic induction. What is the first law says then? First law says if there is a change in the magnetic flux linked with a circuit, then EMF will be induced in the coil. But how much it is induced, that is given by the second law. The magnitude of the induced EMF is given by the Faraday's second law. Question number 12. The ability of a material to conduct magnetic flux through it is called permeability. So permeability, what is mu naught? Mu naught is permeability at vacuum. Permeability in vacuum, we can say. In vacuum. Permeability in vacuum. When it comes to relative permeability, mu r is the relative permeability. Mu r equal to what? Mu upon mu naught. What is mu? Mu is the permeability of material. Permeability of substance or material. Substance slash material. Substance or material. Now, this mu r is the relative permeability. Relative permeability. Relative permeability. Relative permeability. What is the unit of relative permeability? Okay, mu r. We are going to find the unit of relative permeability. Mu is given in Henry per meter. Mu naught also will come in Henry per meter. Okay, so this Henry per meter will cancels out. So mu r doesn't have what doesn't have? So relative permeability doesn't have unit. So it's just a number. So mu of iron equal to 200. Permeability of iron equal to 200. Question number 13. The magnetic field of a magnetized iron bar when strongly heated. When a magnetic material is heated, what happens? The misalignment of magnetic domains happens and the magnetic field becomes weaker. Question number 14. The magnetic field inside a solenoid. So we have a solenoid. Current will be entering through this end and leaving from this end. Here, when DC current flows through a solenoid, we will have magnetic lines of force. It will create magnetic lines of force. Magnetic lines of force will be there. So here, this inside the solenoid, the magnetic field, that is B, is uniform. Only in the center of inside the solenoid. B is uniform inside the solenoid, but outside it's not uniform. So the magnetic field inside a solenoid is uniform. Answer is uniform. And that magnetic field is given by Ni. I think it is Ni or mu naught Ni. Mu Ni. Here I is the current flowing through this and N is the turns density. In per unit length, how many turns are there? That's what turns density. N is the turns density. Turns density. Question number 15. Which of the following is an example of series parallel circuit? Series parallel circuit. This is parallel. This is purely parallel circuit. Two resistors are connected in parallel and supply is applied. It's a parallel circuit. This is a series circuit. This is also a series circuit. Let's see. This is also a series circuit. So the answer. This is what the answer. This is the answer. This is these two R2, R3 are in series, and those R2 and R3 are in parallel with R1. So this is the parallel combination, series parallel combination circuit. Question number 16. The simplest type of atom is atom to exist in the atom to exist in the atom. The simplest type of atom to exist is the dash atom. The answer is hydrogen atom. Hydrogen atom we see we'll have a proton. One second, let me redraw it. We'll have a okay. Here this is the nucleus of hydrogen atom. We'll have one proton and one electron in the outermost orbit. So this is the simplest atom. One electron will be there in the hydrogen atom. That is the simplest atom. Sorry, again I clicked the wrong button. So hydrogen atom is the simplest atom. Question number 17. Flux linkage equals the number of turns flux times the number of turns flux times the area of the corner. Flux linkage equals flux times number of turns. That is the answer. N d phi by dt. N d phi by dt. Flux times the number of turns. So we'll go to the next question. Question number 18. The charging of a capacitor through a resistance follows what law? Exponential law. It follows exponential law. So if you draw of the charge q versus time of a capacitor, it slowly increases. So this is an exponential curve. This is an exponential curve. This charge verges. But what if we draw this is exponential growth actually. It's an exponential growth. If you want to see current versus time in a capacitor, what happens? Initially the capacitor will draw the maximum current, then it decreases. This is an exponential decay. This is exponential decay. So charging is a exponential growth. This is exponential growth. Exponential growth. This current is an exponential decay because current will be reducing. Similar curves you will get it for the inductor also. Exponential decay of current. Okay. The amplifier CMRR common mode rejection ratio of 741 operational amplifier is answer is it is around 70 dB. But for an ideal op amp common mode rejection ratio equal to infinite. Common mode rejection ratio is infinite. And for a 741 amplifier, it is 70 dB. Right value. So that has to be a differential mode gain upon common mode gain, because common mode gain is supposed to be 0. common chord gain supposed to be 0. Then we'll get CMRI equal to infinite. So, okay. Okay, so we'll go to the next question. This is the last question of first part. What is the question? For a full wave rectifier, the output frequency. For a full wave rectifier, output frequency is 2 times the input frequency equals 2 times the input. Answer is equals 2 times. This tau is the input frequency. For a half wave rectifier, what it is? Equals 1 half of the equals line frequency. This is for half wave rectifier. Half wave. Half wave rectifier, the output frequency is same as the input frequency. So friends, thanks for watching, and any doubt or any mistakes, any I have done anything, please update in the comment section, or you can WhatsApp me. And if you are in need of any of these question papers, that is technician B electronics, or fitter, or electrician, or technical assistant electronics and mechanical, or if you are preparing for railway or SSC JE, all these question papers are there. Many question papers are there, all these. So please WhatsApp me to get the question papers. Thank you guys.